Alright, so what we're doing within this video is to introduce a kind of interesting topic. It is called await async. So we're going to go to the module first because I want to show you where the module is. It is already in Canvas. I'm not sure when you guys would find the time to kind of read it, because it's kind of important to read it too. Some people are better at absorbing material and its audio, and other people are better at absorbing material when it is in text. And yet some other people are better yet when it is hands-on. So I think some of the sample code in this module may be helpful for those people who want to. Excuse me, I was just scratching my chin and touched the mic, the windscreen of my mic. Anyway, yes, I also got some interesting background music too. There you go. All right. So the analogy is important because this is something that we can pretty much all relate to. I know there's a lot of text here, and I do not intend to read the text, but it suffices to say that in the case of JavaScript, if you look at a server environment as a restaurant, okay, which basically includes a lot of infrastructural stuff, okay, which is the operating system. In this case, is Linux. It also includes Apache, which is a what we call a daemon, daemon. It is a process that's sitting in the background, and a whole bunch of other stuff. That's the restaurant. What Express is doing is it is the waiter at a restaurant, and the model of Express is there's only one single waiter. Now, I understand in an educational environment like what we are doing on the Power Server, each one of you has a waiter. But in the real production environment, there's only one single waiter, when it comes to Express. So what is so special about this? Well, what is special about this is with a single waiter, you can have any number of customers. Okay, so I'm gonna roughly say that one customer is one table. Okay, it's one particular source of orders. Okay, so you can have any number of customers walking in. So walking in to the restaurant is equivalent to a request coming onto the server. So somebody on a browser like Firefox or Chrome or Edge or Safari type in a URL, got to your website. That is a customer arriving, okay? But that's at a waiting area of the restaurant. When everything checks out, okay, and that's not the job of your script, okay, but when everything checks out, like the HTTPS authentication part, and so not authentication, but the secure communication part, when everything checks out, then the customer enters, into the actual restaurant and get to a table. That is when your Express script comes into play, because what your Express script is doing is to tell the waiter what to do in order to serve customers who just sat down at the table. All right, so the interesting thing between especially between Express and PHP is Express is designed so that you only have one single waiter for the entire restaurant, and you can have any number of customers coming in, and there's an infinite number, well, I would say quote unquote infinite number of tables. So how do you have one single waiter to wait on so many different customers? That becomes the challenge. Now, with other technology like PHP or in the earlier days Perl, basically you have one waiter per customer. So a lot of things you can get away with when you have one single waiter per customer. You cannot get away with when you only have one single waiter for the entire restaurant. Okay, so that is also why there's a little bit of complexity coming from this particular design, but there's also a lot of advantage coming out of this design. JavaScript plus Express is actually far more efficient compared to the more traditional one waiter per customer approach. because when a new customer arrives, you don't need the overhead, the resources needed in order to quote unquote spin up or spawn a new waiter. And when a particular customer leaves the restaurant, you don't need the overhead to also to reclaim the resources allocated to that particular waiter. And I just realized, waiter, await, that's kind of a pun, and that was definitely not intended because I just realized it. Yeah, not funny, but just kind of coincidental. Anyway, so getting into the text here, um, so we have just covered the content of section 2, and we are moving on to section 3. So section 3 talks about a particular um, series as a kid that I really enjoyed watching. It is called the Thunderbirds. So for those of you who want to check it out, you can go check it out. But that was in the opening, after all the music, at the beginning, at the very, very beginning of the opening, they would say, 5, 4, 3, 2, 1. Thunderbirds, go. So, so we are trying to reproduce, that opening using JavaScript or Node.js plus Express or Express plus Node. Okay, doesn't matter. It's kind of the same thing. Because at this point, we are only dealing with, just ECMAScript. Okay, it's not even JavaScript or Node because it is not specific to the server environment. It's not specific to the client environment. It's just ECMAScript, doing some simple stuff. Okay, so we have this, very elemental program. Okay, it's just 5, 4, 3, 2, 1 Thunderbirds a go, and they're all output coming out of console.log. Okay, nothing exciting. By this time, we should all kind of know what this program is going to do. And obviously, this program is not going to serve the web in any way. Okay, this is not a web script in any way because we're trying to focus on the concept of asynchronous and processing. So then the next thing we do is to turn the program into something that looks like this, because this is what you need in order to use what we call a callback function, which will be illustrated later on. But we are defining functions, so this is a very good example of what functions do. So TB5, which is Thunderbird 5, is a very simple function. Every function, has a block of code. The name of the function, interestingly, is optional. In other words, in most other languages like C and C++, functions cannot be anonymous. You must have a name associated with the function. However, in JavaScript, in Python, in many scripting languages, functions can be anonymous. Okay, but in all of these examples, I do not use anonymous functions because I want to focus on the main concept and not so much the notation of how we express the logic. So I don't want to kind of pollute the explanation with anonymous functions. So we have a function called tb5, and all it does is to console.log5. So when the function is called all the way from here, when it is invoked from here, it will simply go to the code, perform what the body of the function defines, and then it returns to the next available thing to do, which is to call tb4. tb4, not surprisingly, is going to get to the body of tb4 as a function. It will perform the console.log operation, and then it returns to whatever is next, which is tb3, and so on. So basically, this particular program, okay, this listing 2, is going to do exactly the same thing as listing 1, except it looks a little bit awkward, okay, because printing 5, 4, 3, 2, 1 is really a sequence of things that we want to kind of put together as a sequence. Now it is not so obvious, even though in in the main program we can see the sequence of calling the subroutines, but if you want to know what actions are actually performed in sequence, you have to get to the definition of the subroutine. Now, when your subroutine only has a single line, it is not a big deal, okay? However, if your subroutine is specifying logic that is like a chunk, like 10, 20 lines, and you have to basically break it up, fragment, that sequential logic into 5 different subroutines and then string the subroutines together to form a sequence, that's really kind of, I mean, it gets the job done, but in terms of the readability, it's not so intuitive anymore. All right, so why do we have to break it up into all of these functions? It's because we want to set up the program to utilize callback functions so that we can set up delays. So the next program is going to use a delay mechanism. So this is a very simplistic program in when we get to listing 3. What it does is it uses a built-in function called setTimeout in ECMAScript. I believe this is in JavaScript and also in Node, so it is not specific to either one. And it's built in. You don't have to require a particular Node module in order to use this. So setTimer is interesting because when TB5 is called, for instance, in this case, it will first execute the first statement. Okay, the first statement just prints a 5 onto the console, and then the second statement, which is the set timer statement, is going to do something that's interesting. It has 2 parameters or 2 arguments. Sorry. So the difference. Okay, I have to turn off the mic because I have to scratch my chin again. Alright, hopefully that takes care of the cat hair issue because it's the cat hair on the mic windscreen that's touching my chin, touching my skin and causing it to itch. Right, okay, so getting back here. It takes actually 3 potential arguments. So when you are calling a function, each item within the parentheses is called an argument. But when you're in a subroutine definition, what appears within the parentheses over here, they are called parameters. So parameters is from the perspective of the definition of a subroutine, but arguments are from the perspective of the invocation or the calling of a subroutine. So that those terms are kind of important, even though a lot of people use those 2 terms interchangeably, but they are really not exactly the same thing. So getting back to here, so the first argument is tb4, which is the name of another function. So this is really passing a function tb4 into setTimeout. It is not calling tb4, it is just telling setTimeout what function to call after 1000 milliseconds from the time that setTimeout itself is called. Let me say that one more time because I know this can sound a little confusing. So what setTimeout does is to say after 1000 milliseconds, okay, or you can change this number to whatever you want, tell me which function I should call after 1000 milliseconds. So that's what the first argument is doing, is to specify what function to be called after 1000 milliseconds. So naturally, the first question is, so who's going to call tb4? And the answer is quite interesting. It is not your script. Okay, so your Express script does not explicitly call tb4. It simply specifies after 1000 milliseconds, somebody is going to call tb4. So that somebody is actually the node event loop. Okay, and that's a pretty it's a concept that we don't need to get into right now, but there's an event loop, sitting in the background of every single Node or JavaScript program, and that is kind of like, sort of like the operating system, but within the environment of Node. And that background thing that you have no control over would take note to basically after 1000 milliseconds call tb4. Okay. In other words, this is equivalent of the waiter taking an order, such as a medium rare steak, okay, which takes a little bit of time to prepare, and go to the kitchen and just drop off that specification. I need a medium rare steak, but on the slip of order, it will also include. Oh, by the way, when you're done, page me. Okay, page me so I can tell you what to do after the steak is done. That instruction, okay, in double quotes, okay, page me when you're done, and I will let you know this is what I need to do after that. That is what TB4 is. Okay, it is an instruction of when the job is done. Call me, okay, let me know, and then I'll continue operation after 1000 milliseconds. In this case, in the case of the restaurant, it will be the waiter basically saying, okay, when the steak is done, I'm going to, take it back to the table where this was ordered. That would be what is equivalent to TB4 in the restaurant analogy. Okay, it contains the additional information or instructions of what to do after the asynchronous event is done. All right. So in the restaurant, the asynchronous operation is how long the kitchen is gonna. It's the kitchen cooking. Okay, preparing the medium rare steak. In this particular program, it is basically just a timeout mechanism. It's like, okay, wait 1,000 milliseconds, and then the event is done. Okay. So I hope this is clear. Let me take a look at the time because I got to leave in another 25 minutes or so. But this is a good time to make a proposal. I'll get back to this, but I want to also make this proposal before I forget. There we go. So what I'm proposing is to set up a you're going to say this is probably a pun because I want to set up a synchronous lecture time and potentially a lab time for this class. And I'm going to specifically say that this is optional. In other words, if people cannot show up during this time, I'm not going to count people as absent as I would with my other classes, because all of my other classes are synchronous, which means I have real-time, face-to-face, just over the network type of lecture and lab. But with this class, okay, the way it's specified on the schedule is it is asynchronous. So I cannot require people to show up, during a synchronous, session. However, I believe some people may like to have a synchronous lecture / lab session. So that's what I'm proposing. Okay, if none of you come back to me and say, yeah, I would like to have a real-time, face-to-face interactive session, either for the lecture, which is basically me doing exactly what I'm doing right now, explaining the concepts, kind of doing some experiments, doing some demonstration. It's mostly one way, except you can ask questions. Okay, so you can say, but I'm not quite getting what set timeout is doing here. Can you explain in a slightly different way? So you can interactively, talk to me and let me know what you want me to explain further. And the lab session is just going to be me allocating, some amount of time. So I'll be, for the most part, sitting around in that case. So I'll be your waiter, I'll be your server, and then you guys will be doing your lab during that time. So when you come into some problem, like, okay, I'm not really sure what's going on with PM2, it doesn't seem to be starting the app that I want to start, then you can interactively use Discord to send me a screenshot. You can, send me a video share or screen share so I can actually look at your screen to see what's going on. So that would be a time for me to interactively help you guys to figure out the lab and so on and so forth. Okay, so the key is synchronous. In this case means in real time. I can not have this class to overlap with my other classes and certain responsibilities that require specific time slots. That leaves okay, so on Mondays, I would say from 11 a.m. to about 2 p.m. I am available, but obviously I cannot make it a 3-hour session, but I can make it maybe a 1-hour session or something like that. And the same goes for Wednesday. So Wednesday is the same. On Tuesdays, let me think about my schedule. So on Tuesdays, I have time mostly in the afternoon, and I'm just thinking about what I need to do so I can give you guys a clear option of when I can be available. So I would say from 5 p.m. to about 7 p.m. Okay. Once again, I'm not suggesting to make this a 2-hour session. Maybe just 1 hour, out of this time frame. And I cannot do this, with some people. I'm gonna use this time frame, and some other people use another time frame. So this is a time frame for the entire class. Um, well, simply because I don't have all the time in the world. I mean, I still need to save some time for other things, that I need to do other than teaching. All right, so let's talk about Thursday. So Thursday is a little bit interesting. I can actually be available earlier, um, only on certain Thursdays. So let's not do that because I got some meetings that only happens like once a month or so. But still, I don't want to use up that time slot. So I would say, on Thursdays, it's also going to be from 5 p.m. to about 7 p.m. And then on Fridays, I typically have time generally after 2 p.m. And I'm going to say 2 p.m. to about 5 p.m. All right, so these are my available time slots, okay? And you guys need to kind of, I need to find a way to poll, uh, when you want the synchronous session to be allocated, if you guys want it, at all. So I'm gonna set up a survey. I'm gonna set up a Google form survey in which it will have basically it will chop these time slots into 1 hour durations, and then I'll just collect when you guys are able to make it to which time slot, and then whatever time slot that gets the most people being available and interested will be the time slots for the class, and I can pick out maybe like 2 or 3 or even maybe up to 4 of those slots. So that would be the synchronous time for this class, because I think that should help. Okay, I think that's probably a useful resource for this class. So keep this in mind. Okay, think about your own schedule. So by the time I send out the form to kind of poll the class, you will have your answer already. Okay, so sidetracking back to my original presentation. So what is interesting about set timeout is it comes back right away after it puts in the order with the kitchen and say that, hey, I need a medium rare steak, and this is my cell phone number, and this is the instruction for you to send back to me after the steak is done to remind me what to do with the steak. Right after the waiter drop off this piece of paper. Okay, this is just a tiny little piece of paper. It takes almost no time to write up the order and drop it off with the kitchen. The waiter immediately comes back so that the waiter can wait on other tables. Okay, possibly the same table, because once you order the steak, you can get back to the same table and ask the customer, would you guys like to get start with some wine? Would you like some water, or some other task, right? So this is the important part. Once you place the order with the kitchen, once the waiter places the food order with the kitchen, the waiter becomes immediately available again to continue to work on some other stuff. This is the big difference between synchronous programming and asynchronous programming. This is asynchronous programming. You are basically just leaving an instruction that takes a long time to complete, and then you immediately continue so that you can see, okay, let's see what else I can do, while this is being done by somebody else. Okay, that somebody else in this case is simply a timeout mechanism in the background. It has no specific name. And other times it can be a database operation. Other times it can be a RESTful API call to another server, and so on and so forth. Okay, so there's no limitations as to what is being done. That takes a long period of time. All right, so when TP5 is done calling this, it will come back right away. and it's gonna. So the interesting thing is the program only calls TB5 itself. So when TB5 is done, it goes back to this part here, and it would appear that the program is already done. But that's not happening because ECMAScript, generally speaking, that includes Node and JavaScript, the environment realizes, oh, wait, I cannot get out of the program yet, okay? Because you specifically told me that I have something to do. When I'm done, I'm supposed to get back to you, to the waiter in this case, so that you have, you know what to do after that. So the program is not going to exit because we still got some, excuse me, we still got some unfinished business at this point. So, so even though it would seem that program should terminate at this point, it does not. Okay. On the other hand, if you put a console log right after DB5, it would print. Okay, that message would be printed right after console log 5, because technically speaking, you are getting to the instruction or this statement right after TB5. It is just that the program is not quite ready to exit yet, because there are still things that they need to do. So after 1000 seconds, TB4 is going to be called. And as I said, it's called by the environment itself. It is not your code that is calling TB4. When TB4 is called, it will print forward to the screen, to the terminal, and it will set up, so that 1000 milliseconds after that, it's going to call, the background is going to call TB3, and TB3 sets up, it will print 3, and then it will set it up so that after 1000 milliseconds, which is 1 second, it would call the background, would call TB2, and then TB2 would do the same thing to call TB1, and then TB1 finally would print TB go, would call, set up for the background to call TB go, and then TB go is just going to print Thunderbirds are go without using set timeout anymore. So when TB go is done, then the environment, the node environment or the JavaScript environment is going to say, oh, okay, I can see that we have no operation that is being done, and there are no callback function to call back anymore. So when TBGO is done, okay, then the system will finally say, okay, we're done here, and then the program would exit at that point. So these programs, you can all type it in and test it. I would not suggest you to copy and paste from the browser, because the encoding of some of the symbols, such as the quotes, may not be compatible with Node.js. It might work, it may not work. So you can give it a try if you want to, but if it doesn't work, then you just have to kind of type the whole thing. All right, so I'm just looking at the time here. I got another 15 minutes or so. So section 3.4 uses a very kind of, it sounds like a very obscure concept. It's called a promise. So what a promise is a little bit complicated. The best way to describe a promise is it's kind of like in programming terms, it's called an encapsulation. It's an encapsulation of the concept of a callback. So in the previous program, TBGO is a callback in this context. TB1 is a callback in this context. In other words, you're basically specifying, hey, your background, when a certain thing is done, call this particular subroutine. That's what a callback is. When you are using a promise, okay, so the way we use a promise here is this kind of special function here. Alright, so this function is called delay. It takes how much time to delay, which is specified in milliseconds. So the delay function is interesting in several ways. First of all, we have a function defined within of the definition of function. So nested function definitions are actually fine in JavaScript, and in fact it can be nested. So we have timeout handler defined within delay promise handler, which is then defined within delay. And that's perfectly okay. However, we have to understand the scope of all of these names. So timeout handler is local to delay promise handler. In other words, outside of delay promise handler, timeout handler as is defined here, is not visible. And the same thing is also true for delay promise handler. It is local to delay, which means outside of these, the first and the last brace, delay promise handler cannot be accessed by anyone else, by anywhere else in the program. It can only be accessed or utilized within delay. So now we need to kind of think about what is going on here. So when you look at, okay, we can go from the inside out, go to the deepest portion. So the deepest portion is timeout handler, which is a function. It takes delay millisecond as a parameter, but it doesn't really use it. That's probably by mistake, specifying that parameter. But it's okay. It doesn't have to use a parameter. And all it does is to say resolve. Okay. So where's resolve coming from? Resolve is coming from here. So resolve is not even a parameter of timeout handler. It is actually a parameter of resolve. So this is the other thing that's really cool about ECMAScript is a nested function actually has access to the parameter of the nesting function, and that goes in any level of hierarchy. So millisecond period is actually accessible to timeout handler too. So the next question is, okay, so now we define timeout handler. It is calling resolve, which is a parameter to delay promise handler. How are we going to use delay promise handler, and what does it do? So delay promise handler got one thing to do. All it does is to call set timeout, which is what we did earlier. And as you recall, when you use set timeout, you have to give it at least two pieces of information. One is how many milliseconds to delay, and the second one is when that time is up, what function do you want me to call? So in this case, it is timeout handler that gets called after this amount of time. This is an argument that we are passing to set timeout, but it is a parameter of delay. So then the next question is, what are we doing with delay promise handler? So the way we use delay promise handler, which is a mechanism that we are fairly familiar with from before when we talk about callbacks, that one is used when we create a new promise. So delay itself is really just returning a new promise object. Now when you use a promise object, you have to give it a at least one callback, and that callback is to specify how do we start the operation? Okay, what am I supposed to do, for this particular promise? So what we are supposed to do with this promise is really this code over here, the highlighted portion, which really only consists of set timeout. But we are wrapping, the callback mechanism within a promise. And you might say, so what is this buying us? Okay, this looks really complicated. What is it going to buy us? Well, what it buys us is we can use the then method of a promise. So TB5, okay, is right here. So TB5 is going to print 5 to the console, and then it's going to return delay 1000. And delay 1000 is basically calling this particular subroutine with ms period being 1000, but eventually all it does is to return a promise and also get started with the operation specified within its callback. Okay, so a promise has a callback, which is delay promise handler in this case, and all it wants to do is to set the timeout. But when the timeout is done, the callback of this timeout is going to call resolve, and resolve is actually a function that belongs to a promise. So when the promise is resolved, then the promise is fulfilled. Then the .then method is going to be called. So this is a very obscure way to associate a callback with a .then method of a promise. But the nice thing about this is now we can finally sequence, okay, when TB5 is done, then TB4 is going to perform. When the TB4 callback, when the callback associated with TB4 is called, then we are going to continue to call TB3. The background is going to call TB3. When TB3 is called, it will set up a callback. When that callback is called, then we will get to the .then that will specify TB2 as the callback. When TB2 is called, it is setting up the delay and also at the same time specifying the callback. And that callback is going to trigger the then over here, or get to the then over here, and then TB1 is going to execute, and then TB go is going to execute. However, it is very important to understand that this statement here is not synchronous. It is asynchronous, which means this will take almost no time to set up, okay? Because all you're doing is setting up a chain of callbacks, okay? You're setting up a chain of callbacks and it returns right away to the end of this program. In other words, if I were to insert a console.log after this chain of thens, it would actually print immediately, and then we'll get to see the 5, 4, 3, 2, 1 Thunderbirds or go. Because all this is doing is, instead of leaving behind one order slip with the kitchen, you are stapling a whole bunch of such orders with the kitchen. So in between, when the steak, so okay, let me give you a more realistic example. So you might be you have, let's say the customer is ordering a suite instead of a specific dish. So it's a suite that includes the appetizer, the entree, the appetizer, soup, salad, entree, and then dessert. Okay, so there are 5 items associated with the suite. This is basically setting up a stapled stack of food order. And this one here is setting up the steak. This one here is setting up the, what is the next one? No, I take it back. Sorry. The first one is the appetizer, and then we got the soup, and then we got the salad, we got the entree, and then we got the dessert, and then we are going to have the customer to pay up. Okay, so all of these instructions are basically written on different order slips. So TB5 is an order slip that basically specifies, okay, go ahead and get the appetizers ready. But it also contains the instruction. Okay, so when you look at TB5, it would get, what delay is doing is getting started with the preparation of the appetizer. But the callback, okay, this resolve here, okay, the callback itself is timeout handler, but when the callback is called, it is doing the resolve. So what the resolve is really doing is triggering the flipping to the next page of the stapled order, okay, the stacked up order. So resolve is basically giving it's a mechanism go like, at this point of time after the appetizer is done, then go ahead and get the soup ready, or then you specify what to do next, and then that function gets called. When resolve is called, it triggers whatever is specified in the .then, in this case TB4, to be called. Alright, and when TB4 is called, it would do about the same thing. The first thing is, okay, we need to get started with the soup, and it's going to call delay, which is setting up the mechanism to have a callback, which is timeout handler, which is not seen by the outside of the program. But what it does, that is affecting the main code here to execute, is the callback is going to call resolve. When resolve is called, then it will trigger whatever is specified in the next dot then, which in this case is TB3, and so on. So comparing the promise code with the previous code, which is only using callback, the promise code has a few advantages. One, it is quote-unquote object-oriented, which I'm not going to get too much into in this case. But the second one is how it looks like, okay? Because now it looks, hey, at least we can string TB5, TB4, TB3, TB2, TB1, and TB go into this quote-unquote sequence. But it is still asynchronous. In other words, this takes almost no time to execute. This is just basically the waiter, preparing the instructions. Okay, we need the appetizer, soup, salad, entree, dessert, and then have the bill ready for the customer to pay. And basically the waiter has the entire thing stapled, so that the completion of each phase is going to trigger the execution of the next phase. And but the key idea here is the callback is now encapsulated within a promise. So that means instead of having this mechanism where if you want to know what happens after TB5, you have to go to the definition of TB5 to understand that, oh, so TB4 is the next thing to do. What about after TB4? You have to get into the definition of TB4 to understand that TB3 is the next thing to do. What about after TB3? You have to get to the definition of TB3 to understand that after TB3 you're performing TB2. So that's one difference. But the most important difference is, what if a different customer wants to have appetizer and then skip the soup only to have a salad, and then have the entree, no dessert, and then get the bill? Well, in this particular fashion, it's easy to do, because all you have to do is to say TB5 dot then TB3, because you're skipping the soup, dot then TB2, which is the entree, and then dot then TB go, because you're skipping the dessert. So this allows code to be a lot more modular, because when you look at each callback, it does not itself specify what is the next step. All it does is to say, I know how to get my job done. I don't really know what what is to be done after this. I'm gonna just use the mechanism in delay to resolve the promise. When the promise is resolved, then whatever is specified with the dot then is the next operation. So the promise code is more modular, because you can reuse code and resequence what step should follow which other step, as opposed to the callback method, which is a lot more rigid, because in TB5 you have already spelled out after TB5 we're supposed to do TB4. In TB4 you have already explicitly specified that after TB4 we're supposed to do TB3, and so on. But the other code using promise is much more flexible, because now you can resequence, skip a few steps if you want to, when you specify all the dot thens. The problem with promise is it is still kind of obscure. Okay, it is still asynchronous, which means you cannot really specify something like, after this I need you to do this, and that code does not have anything to do with promises. It's possible, okay, because one of these dot then thing doesn't have to return a promise, in which case it would just be performed, and you can do that. However, it is very cumbersome to have your entire program being specified by a long chain of these dot thens. And besides, the logic, the sequence of operations to do, they will still be chopped up, into subroutines. Even if they're anonymous subroutines or functions, they're still chopped up. So we don't like the idea of having things chopped up, because it becomes very difficult to read. So I'm out of time right now, so I'm just gonna stop this recording and I'll upload everything when both videos are done. So I kind of have to do the next part when I come back. All right. So I'm gonna stop this one now.